Hi folks. So I finally buttoned up that Sansui 9090 dB that literally took me down to my last nerve. Got it boxed up, gonna try and get it shipped out tomorrow. And would you know, I have a Sansui 9090 non-dB. Now I've had this one before and you may find some videos on my channel. Every time I found it, it was brought to me, I found that it had blown fuses, the rail fuses that go to the outputs. And first time it was the right channel, led me on a merry chase because I had some bad cables I was testing with. Anyway, then it was brought back to me with bad fuses on the left channel. And I never found anything else wrong. But this last time, the gentleman who owns it brought these speaker terminals with me, or speaker cables he was using, and they were probably the most ill-conceived product I had ever seen. They were metallic barrels, roughly about the diameter of an RCA like this, with wire sticking out. And he had the wire in the speaker terminals, but these metal pieces could touch each other. And apparently that's what was happening and blowing the fuses. I took some heat shrink while he was here with them. I insulated them, but oh my God, I was just dumbfounded that anything like this would be manufactured. In any event, now I believe it took out more than just the fuses. I found blown fuses in here, but I replaced them, it stayed in protection. So I've got on the dim bulb tester, got fresh fuses in there, and I think it's gonna glow the bulb brightly. I haven't even tried it yet. So let's see what we get here. Okay, so I got it plugged in the dim bulb tester, a 100-watt bulb in here, and let's see what we get. We get pretty much what I figured we'd get. We have a dead short in here. Chances are it's output transistors. I'm going to take a look at those, and we'll have to take it from there. Okay, so I've got these long probes on here, and we're going to see if we have shorted outputs. Now the fuses are on the left side, so I suspect that these transistors are going to be shorted. So let's see. Emitter to collector. Shorted. Other channel. Other side here. Yeah, I think all the outputs are shorted. Let me look at the other channel. Yeah, the other channel looks okay. So we have shorted outputs at least, and many times this can cascade back. So I'm going to pull outputs, we're going to pull the driver board, start looking at drivers, and see where our damage stops. I'm going to print out a shot of the output stage so we can mark it and trace the path of destruction. That way we'll know when we finally got everything. Okay, so I printed out a schematic. Now, the way this amplifier is laid out, they show an interconnection diagram, and the output transistors are shown at the bottom. And then the power supply shows the emitter resistors, and they're laying back here behind the driver board. It's just the way they did it for this model. This is the driver board. So I know we have bad outputs, we just have to see how far the damage went back this way, and then we have to go down in here and check our emitter resistors. Now, these are the shorted outputs. I put a piece of tape on this side. They're on the left here, they'll be on the right here when I flip it around. But just to keep me from getting distracted, making a mistake, I put a piece of tape here so I'll know which ones to pull. I jokingly say I haven't made every mistake there is to make, but I'm working on it. That's kind of not a joke. I have made so many simple mistakes like that I try to do things to mitigate that whenever possible. Piece of tape here just lets me know that. So we're gonna turn this around and see about pulling the outputs out of here. All right. I'm going to pause this while we get the back shield off. Okay, so I've got the back off and the heatsink assembly also, because this is just the cover for the heatsink assembly, which I have here. Everybody, I believe, has seen my bag system. I'll have a master bag. I just repurposed the one from the 9090 DB, crossed out the DB part, and I put everything I take off of there into what I refer to as the master bag. And this way it kind of keeps everything together. And in the event that things get separated, something else I do, and I'm not sure how well you can see this, but I have written in here what this came off of. This is the 9090 back. So in the event that they somehow get separated, I'll know where this goes and what it belongs to. It's, as an engineer friend of mine once said, it's easier to stay out of trouble than it is to get out of trouble. Can't remember how to say it. No wonder I can't seem to stay out of trouble. Jeez. Okay, so now we're going to start pulling these transistors out of here and checking them, but I'm pretty sure they're all going to be shorted and they're all going to have to be replaced. So the tape reminds me I'm actually pulling them from the right side, even though it's the left channel because the unit's turned around. So take all the screws out of the transistors. Keep a rag handy. This heatsink compound gets on everything. And try to remember, wash your hands before using the bathroom, and you'll find it in places where no man should find it. Please don't ask me how I know this. And by the way, a good cordless screwdriver is a lifesaver. I've had this one for probably over 10 years. Came with 2 batteries. They charge up in a half hour. They seem to last forever. It was about $70 when I bought it. Worth every penny. I really like the Hitachi hand tool line. Okay, so let's get another bag for these transistor screws. 1 pair, 2 pair, 3 pair, 4. That's all of them. Mark the bag. Okay, so now we're going to start checking these. I'm going to wipe the heatsink compound off my hands. And we'll start pulling these out. Okay, first one. Okay. These are on semi, so they've been replaced. All right. Now check the first one here. This one's good. All right, first one's good. If any of them have blown though, they're all getting replaced. You never know what stressors have been put on a unit when you have an output short. Can definitely shorten the life of the others. This one's shorted every which way. All right, so we know that one's bad. Now this, I believe, is a quasi-complementary, meaning all the outputs are NPNs and the drivers to the outputs are NPN and PNP. Back in the early 70s, it was really hard to get good power PNP transistors. So this was the design that was the compromise. This one's good. That was a mistake. Okay, so those 2 are good. Chances are this is going to be shorted. Or not. Anyway. Yep, this one's shorted too. Just like the other. So both the ones on the bottoms were shorted. So we're going to take a look at the schematic and see where that leads us. And we're going to have to check the driver board. The chances are pretty good. We're going to have a problem there. We're also going to have to go down in here and take a look at the emitter resistors. So let's pause this and pull the driver board. Okay, so it looks like we got lucky, and it's not uncommon with Sansui's. Sansuis are very well fused for the most part. The AU717s I've worked on, the 9090 series I've worked on, all have many fuses in there. I've seen amplifiers that have a single power fuse like the one on the back here, and that's it. And the damage is usually far more profound than I've found in here, because I didn't find anything wrong on the driver board. Now this particular model doesn't have these, which are actually base resistors that go to the outputs, but I checked here and our drivers are good. Our drivers are these guys on the heat sinks right here, and they're easy enough to check. Just check them like we check all our transistors. We go to diode test mode. This blue guy is a PNP, so we're going to put the black lead on the base, and we should get 0.6 volts, and we do. So that's base to collector is good, base to emitter is good. We're going to do the same thing on, let's see where this is. It's really hard to see down in here, but we want to check this guy. So that is going to be like this. Let's see, that should be, that's good. And there we go. So the drivers are both good. So now all we have to do is match up 4 output transistors, replace them, check the bias, and we should be good to go. Okay, so this is my curve tracer. It connects to the oscilloscope, and these are the transistors we're going to test. And you can switch between this transistor and this one to see if the gain characteristics are the same. So we just put the scope in XY mode, turn it on. You can see we got a family of curves on the screen. Okay, so let me see. This one is giving us about there, and we switch to the other transistor, and they are very well matched. So, see if we can find some others that match these. We're going to need 4 total. I have a bunch of them, so I should be able to get a decent match. Okay. That actually looks pretty good. That one's a little low, but we're going to keep this one. We just need one more. Now, it was a QRX Restore, I think, will sell you matched sets of transistors for the 9090. And if you don't have a curve tracer, that'd be the way to go. All right, that looks pretty good. So, we have 4 matched transistors. So I'm going to install these, and we'll leave it on the dim bulb and see what happens when we bring it up. Okay, so I've got 4 matched transistors reinstalled. I put new micas on, and when you go through something like as many of these as I do, buy them by the 100. They're cheaper, and it's just better to have them on hand. You always want to replace these. Like I said, they're cheap enough. They also make what they call sill pads, where you don't have to use this nasty heatsink compound. People have their preferences. I think they're both equally good, but I have a lot of heatsink compound. And by the way, you use this very sparingly. A tube this big should last you for years. It'll probably dry out before you use all of it. I ended up buying a 1-pound container of this. It was cheap, and I was putting my dummy loads together, and I needed to slather a lot of heatsink compound on them. It's not a void filler. It's just supposed to make up for imperfections between the heatsink and the transistor body. So we've got this back on. We got the driver board back in, and the whole point of having a schematic printed out like this is if these drivers were bad, we'd have to start checking all the resistors and start checking back to see if we had other blown transistors. And when you don't find any more damaged components, you should be good. But we didn't find anything on this board, and I chalked it up to being well fused, as most Sansuis are. So now, the moment of truth. Is it going to glow the bulb brightly, or is it going to come out of protection? I haven't set the bias on this yet, and I'm going to have to because I changed the transistors. But let's just see what we get over here. Drum roll, please. Looks good. And I just heard it click out of protection. So apparently that's all that was wrong. Next step, we'll go through, we'll set the bias, check the offset, leave it cook for a while, put some signal through it, and see what we get. Okay, this is the procedure for setting the bias. Again, I've done this on my channel before, but just for the interest of completion, I'll show you what we do. Now, I want to check the bias first. I'm going to leave it on the dim bulb, even though I'll have to take it off to get the final adjustment. I like to leave it on the dim bulb in case the bias is extremely high, because these transistors can go into a phenomenon known as thermal runaway, which is just as bad as it sounds. The transistors just start to draw more and more current until they self-destruct. And what Sansui has you do on this model, I'm not crazy about, but we're going to do it their way, is you remove one of the fuses on each side, and you put your milliamp meter in series with it. Now, I don't want to have probes in there and have to worry about that. So what we did, Popular Audio Forum I'm a member of, said take a blown fuse and solder a couple of wires across it, put it in the socket, and on the other end I've got bananas to go in the meter. That takes all the danger out of it. I do it with the power off, turn it on, we're good to go. So I'm going to pull this fuse on the left channel. We're going to pop that fuse in there and see what we get. Oh, it certainly popped out. Okay, so the fuse is out. We take our test fuse and seat it down here into the socket. Okay. I'm just going to tilt the camera forward so you can see what we've done here. But here is our fuse. All right, so let's get the meter up here so you can see what's going on. We want to turn it to milliamps, and it defaults to AC, so we need to change it. Make sure we are on DC milliamps. And that should be good. You go into the negative terminal and 400 milliamps on the meter here. Your meter may be a little different, but this is the way this one is set up. Let's see here. Is that better or worse? Oh, that looks good. And this is the pot we're going to be turning back here. So I'm going to turn it on, and according to our schematic, or our manual, it says that we want, and Model A is the 9090. This is for the 8080 and the 9090. Model A, you can tell from the specifications, is this model. Model B is the 8080, is 30 milliamps. So we want to have 50 milliamps. Now, it's going to be less on the dim bulb, but I just want to see what we have, because remember, we changed the outputs. You're supposed to leave it on for about 3 to 5 minutes before you make any adjustments. Okay? You can see here, we adjust the doesn't take much. Okay? So I'm going to take it off the dim bulb, put it on here, and we're going to wait about 5 minutes. So I'm going to pause the camera while we wait. Okay, so the directions here say, before adjustment, run the unit for more than 4 minutes and check and readjust if necessary. So it's been about 5 minutes. And we're supposed to set it right about 50. So it's pretty close. There we go. That, my friends, is close enough. It says 50 plus or minus 1. So that looks pretty good to me. Now the other thing we want to check is the offset. The offset's very easy to check. You just check it right at the speaker terminals. So I'm going to hook up to the speaker terminals on the left channel. We're going to take a look at that. Okay, so I've got it connected to this meter. I still have the other meter measuring the bias over here. And according to this, our offset should be 0 volts plus or minus 0 volts plus or minus 10 millivolts. We are at 6.5. We're going to leave it right there because if you've ever tried to adjust these, they're extremely touchy, and that's more than good enough. So I'm going to connect it up to the analyzer, see what it does. Then we'll play some YouTube music, and this one will be pretty much done, except the owner wants the speaker terminals changed out. A task I truly dread. I don't like hacking up vintage equipment, and this looks like it's going to be a bit of a pain. But I think I know how I can do it and also make it reversible, which is very important to me. Okay, so I got it hooked up to the distortion analyzer, and I don't have the heat sink on here, so we're not going to run it up for long, but we're going to see what we get out of here. And we are looking at about 100 watts. Just starting to clip a little. Okay, there's some imbalance. Unfortunately, that's normal as the volume pots wear out. But anyway, we have good signal out of both channels. I'm going to hook it up. We'll play some music. I want to talk briefly about what happens here. You have an amplifier stuck in protection. You've got two scenarios, and pretty much only two scenarios. First one, your protection circuit is doing its job. Your amplifier is outputting excessive DC voltage. Your amplifier's protection only looks for DC voltage. And if one channel or the other, and it is generally one channel or the other, has a problem, your amplifier protection relay will not close connecting the amplifier to your speakers. It's there to protect your speakers, not the amplifier. However, there are also occasions where you'll find that there's a problem in the protection circuit itself, and that's why your relay isn't closing. So you need to check, and the easiest place to do this I've always found is either bias test points and ground, either bias test point and ground, or ground and just any emitter resistor on either channel, whichever is easiest to get to. All right, if you don't have excessive DC, it's time to start looking at your protection circuit. So I'm going to grab some YouTube safe music here, and we're just going to play something, and then I have to go to bed because it's a work night and I have to go to work tomorrow and make the internet keep working. I work for a large telecom company, and anymore that's pretty much all we do. We're just pushing data around because everything is data. Voice is data, video is data, data's data. So let's pull this out. Okay. And I really need to download some more YouTube safe music because I keep playing the same things over and over.
Make a smile until I look. But if I lay down and I play dead and I stay dead, maybe you'll get sick of being the monster out of my head, under my bed, thinking something out of my nightmares, sitting right there. But if I lay down and I play dead and I stay dead, then will you get bored of killing me? Silhouettes of you are like a taunt. Never really know just what you want.
Okay, so this guy's working. Now I just need to figure out what I'm going to do with the speaker terminals. But anyhow, this one is fixed. So with that, I thank everyone for watching, and I like giving back to the community that's given me so much. Thank you.